Hey, Mr. Sams. We just got done with the holidays, and you've been eating a lot of junk, haven't you?
I most certainly have.
Like that Cheeto. What are you doing with the Cheeto in your hand?
I'm staring at it, and I believe I'm going to eat it.
Why?
Because it's yellow and delicious looking.
Delicious looking. It's processed, Mr. Sams.
Oh, but look at it.
It's not good
it's
for
just
you.
Begging
Isn't
to
it
be
not
eaten.
good for him? Begging to be eaten? I don't think you should eat it, Mr. Sams. I think it's going to poison your gut and stuff.
Why?
Well, it's got like preservatives. You'll
Well,
be like preserved forever.
That's why you have a liver.
Okay, well, whatever you want to do, but I ain't putting that stuff in my body. No. So, we're talking about energy today, Mr. Sams. Thermal energy and heat capacity. So there's energy in that.
There is.
Quite a bit.
This is why I eat them, so I can have lots of energy.
Yeah, but it's not the kind of energy that's going to help build muscles.
Oh,
you want good, strong muscles.
Ah.
And that stuff just, it turns into fat.
How much energy is in this?
I bet we can figure that out.
All right, let's do that. Before I eat it, I kind of want to know how much is in there.
All right, well, let's get on the lesson then.
Okay.
All right. Well, before we get there, we should probably talk, how do you measure energy?
Oh, okay.
Well, what unit measures energy? The answer is a calorie. So we could determine how many calories are in the Cheeto, right? Okay, so now what is a calorie? Well, it's the energy it takes to raise 1 gram of a substance 1 degree Celsius. Actually, this is wrong, Mr. Sams. It's 1 gram of water. 1 degree Celsius.
You're
so
right.
a calorie is 1 gram of water, 1 degree Celsius.
That's
so
the energy it takes to do that.
yes,
Yeah.
the energy it takes to do that is called 1 calorie of energy.
Now, that we should actually make a distinction here.
Yeah,
because
that's true.
A food calorie is actually a kilocalorie.
It's 1 kcal.
So, or 1,000 little
which
calories.
Is 1,000 calories.
So when you look in the back of your candy bar there and it says, 250 calories, that's actually 250,000 little calories.
In fact, they actually use a capital C calorie to indicate that it's a kilocalorie. So yeah, that's actually true. So that's a calorie. Now, scientists aren't always that interested in using calories though.
Right.
There's another unit for the SI system, International System of Units, called the joule, named after Mr. Joule, Prescott Joule. Cool picture of Prescott here. Looks like an old
I love that
guy.
beard.
Yeah,
I wish I could do that.
Yeah, I could.
I can't.
Oh, I could easily do that. What is the basic unit of energy in the SI system is called the joule, and the conversion for calories to joules, there's 4.18 joules in a calorie.
Okay.
And that's a little calorie.
All right, and we abbreviated J. I see what
Capital
you got there.
J.
Okay.
Yep, that's correct. Let's not worry about this now.
Yeah, we don't care about that.
Okay, that's physics stuff. Okay, so how do we measure energy? Energy is a tricky thing to measure.
It is. We have to measure changes that occur in order to measure our energy. So the way we're going to do it in here is we're going to use water.
Yeah, we're going to heat up some water or cool it down. In this case, we'll probably heat it up. And if we know the mass of the water and the temperature of the water, the specific heat is known. Now, there's a new word here, something called the specific heat, and we're going to learn about that a little bit later. But that's abbreviated C.
And it's also called heat capacity.
Heat capacity.
Right. So two different terms. Specific heat and heat capacity are the same thing.
Yep, that's correct. Okay, so there's an important equation called the thermal energy equation. And this is the equation. Q is equal to mc delta T, where Q is your energy.
Yep, or your heat measured in joules.
And that'll be in joules.
Okay.
M is the mass.
The mass.
C is this new thing we're talking about. It's called the heat capacity, or the specific heat.
Sometimes called specific heat capacity.
Right. And then we've got a funny looking symbol there, Mr. Sams.
Delta. Delta means change, and T is temperature. So that's our change in temperature.
That's the change. What do you mean by change in temperature?
Well, you have your initial temperature and your final temperature, and you subtract them, and you get your change in temperature.
So if it goes from 20 degrees Celsius to 25 degrees Celsius, the delta T
is 5.
Would be 5 degrees.
Yeah.
So make sure you understand that this is one term, delta T, not delta and T. It's one continuous thing. Well, I think we should figure out how much energy is in that Cheeto.
Okay, let's do it.
So let's do the Cheeto video clip.
Okay.
All right. Well, Mr. Sams, to prove it to you, that you shouldn't be eating these things, I've got a cool experiment to do. So, here, I happen to have some Cheetos. What you just ate, the nasty, disgusting Cheetos.
Yeah, you know how old those things are?
Like 6 months.
At least.
All right, why did you eat that?
Because it was yellow and delicious looking.
Well, let's just figure out how many empty calories are in this.
Okay.
First thing I need to do is I need to weigh it. So here I'm going to weigh the Cheeto. It weighs 1.28 grams. Okay. Now in this cup right here, or this pop can, I guess, I'm going to place 100 milliliters of water.
Now 100 milliliters of water, that's also 100 grams of water, right?
That's right, because the density of water is 1 gram per cubic centimeter.
All right.
All right. Or per milliliter. I've got my trusty thermometer. I'm going to turn my thermometer on. I'm going to put the thermometer in there. and I find that the temperature is 19.8 degrees Celsius. Now, I'm simply going to burn the Cheeto. Okay, so I've now placed the same Cheeto in the little stand deal there. I'm going to then turn the trusty torch on. There we go. Got basket. And now we are burning the torch, the Cheeto torch. Notice how it burns. And what's it doing to the water is it's heating up the water. And as it heats up the water, we're going to measure the change in temperature of the water. And then we can determine how many calories are in a Cheeto.
Whoops.
It fell off.
We're losing a little bit of our heat to our...
Mr. Bergman knows how to solve that problem.
Hey.
Just do that.
So we have a significant source of error, but we'll be in the ballpark.
Yeah, we're going to be low. So the sad thing is once I get the final number, Mr. Sams, it will be lower than the real answer.
Oh, you're right.
Because all this energy is going to go, oh, it stinks, going to go into, all right, I think we're done.
Yeah.
All right, so now let's go back and do our, oh, hey, one more thing. We need to measure the temperature of the water. So now we need to measure the temperature of the water. And you can see right here, its temperature is 27.2 degrees Celsius. So let's, so we started at 27.2 degrees Celsius.
We started at 19.8
degrees Celsius. So we're going to do the calculations now. So let's do it. Mr. Sams, there was a lot of energy in that Cheeto.
Yeah, there definitely was.
Yeah, so what we're going to do is do the math here.
Alrighty.
Well, we got this equation, Q is equal to MC delta T.
Right.
And the Q is what we're trying to find.
Right.
So what was the mass of the Cheeto? No, it's the mass of the water.
Right. It's 100 grams of water.
That's right. We had 100 grams of water.
And C for water is always 4.18 joules over gram degree Celsius.
4.18 joules per gram degree Celsius.
Notice we're not having any naked numbers. None of that.
Nah.
And the temperature went from 27.2.
Right. 27.2.
That was the final temperature.
Right.
And it started at 19.8, so I'm going to subtract those. And
I take 27.2 and I subtract 19.8.
And you get 7.4.
I get 7.4.
Yep.
So this
that's our
is
delta T.
7.4 degrees Celsius. So I just multiplied these answers out. And by the way, look at the units before I multiply out. The grams are going to cancel here, and so will the degrees Celsius, and you'll be left with joules.
Convenient.
So I'm going to take 100, times 4.18 times 7.4 gives me a grand total of 3,000.
3,100.
Yeah, 3,100 joules. Now, in terms of kilojoules, by the way, that would be 3.1 kilojoules.
Right. Sometimes your answer is asked for in kilojoules, so just divide by 1,000.
So now let's just, for fun, convert that to calories, Mr. Sam. So
okay.
3.1 kilojoules. We want to actually convert to kilocalories, is what I want to do.
Like food calories?
Because it's a food calorie.
Okay.
And I could say kilojoules to kilocalories, and there are 4.18 kilojoules in 1 kilocalorie, right?
Okay.
So that's going to be about 0.8 maybe?
0.74.
0.74 calories per Cheeto.
Okay.
Now, we were low because we dropped it on the table.
That's true. We lost a lot of
I'm
our
going to guess that you were probably off by a factor of 2. I'm going to say per Cheeto you're about 2 calories.
Okay.
So if you ate 100 Cheetos.
200 calories,
200
about what's
calories.
in a can of soda.
Yeah.
All right.
Yeah, so it wasn't as bad.
I like
but
my
still,
Cheetos. That's not
still
so bad.
probably empty calories. But
Right.
that's how you do
now,
that.
Now, these little chocolates we determined a while back, they're like, what, 80 calories each or something like that? So I'd have to eat like 40 Cheetos for the amount of energy that's in one of these.
So which is better for you?
Probably the Cheetos.
I'm thinking so.
Yeah, but the Cheetos are mostly puffy air. You're paying a lot of money for air.
Yeah, that's true.
I prefer chocolate anyhow.
Okay, cool. I'm going to make this. Well, let's talk about heat capacity itself now, or specific heat.
Specific heat.
Heat capacity, specific heat, same thing. So what's heat capacity? It's the heat required to raise the temperature of an object 1 degree Celsius. So if I want to take some pure substance, water, metal, whatever, and raise it 1 degree Celsius, that would be its heat capacity. So specific heat or heat capacity, same thing. These are the same things right here. Is the energy required to raise 1 gram of a substance 1 degree Celsius. And I have a table over here.
Yeah.
So for example, air, it's 1. This is in the joules. 1 gram per joule per gram degree Celsius.
Right.
for air. Aluminum 0.9, ethyl alcohol 2.45. And notice the one that we used a little bit earlier, water.
Hey, that
4.18.
That one's a lot higher than the rest of them.
But it's not that, it's just 4.
Well, that's 4 times more than the metal.
Yeah, actually, interesting thing, guys. A lot of people think that that seems like just a relatively small number, 4.18. Well, it turns out this is a huge number.
Yeah.
The highest specific heat of anything I know of is water, 4.18. Most things have tiny specific heat.
And that's a good thing, because we're mostly water. And if we walked outside on a hot summer day in the sun and water had a low specific heat, we would heat up really, really fast. Yeah. But as it is, our body temperature doesn't change all that much because it's really hard to change the temperature of water.
Yeah, so that's exactly right. Okay, so how can we actually figure out the heat capacity of a substance? Okay, well, the answer comes back to, it's a cool experiment. So let's do an example here to explain it. I can determine the specific heat of a metal. So if I have a metal, you can see there's a metal here in this beaker. I can then measure the change in temperature. The thing weird about energy is you can't measure it directly. I can't just stick it on a scale and say there's this much energy. I have to indirectly measure it by heating up water or some substance. Water's the typical thing that we heat up. And so basically what you can do is you can take a hot piece of metal, put it into some cold water, and you can assume that the energy lost by the metal is the energy gained by the water.
Okay.
And then you can do the calculation. Hey,
let's demonstrate.
We could actually do this very experiment here.
Right, and you're actually going to do this in class if you're in our class. It's a lab, so this will be a little demo on how to get it set up, and then you'll do it in class.
All right, so let's have Mr. Sams do it.
Okay, what we're going to show you now is how to determine the specific heat of a metal. So if you look in this beaker here, we have a piece of aluminum down there in the bottom. And it's being heated in this water, and the water is currently 92 and some change, 92.1 degrees. Okay, so I'm just going to jot that down. That's my initial temperature of my metal, 92.1 degrees Celsius.
Boiling water, 92.1?
Yeah, we don't live at sea level here. We're up a bit higher than that. Okay, so what I'm going to do is I'm going to take that hot metal and I'm going to put it into some cool water, and I'm going to see at what temperature they equilibrate at. So I'm going to use my high-tech calorimeter here. It's also known as a styrofoam coffee cup. And I have 250 milliliters of water. 250 milliliters of water is 250 grams of water. Let's jot that number down. 250 grams of water. Okay, so I'm just going to put that in here. And I also need the temperature of my water. And the temperature of my water is 19.8 degrees Celsius. So that's my initial water temperature. Now, what I'm going to do is I'm going to take my hot metal, I'm going to put it in my cold water, and the temperature of the metal will go down, and the temperature of the water will go up. And eventually they're going to reach the same temperature. So I put that in there, we'll stick our thermometer in here, give it a little stir, make sure everything's moving around. Okay, 21.1, 21.2. Okay, it's going up. All the heat from the metal is being transferred to the water. Remember, energy goes from high to low, or hot to cold, when we're talking about heat. Okay, 21.4. Maybe where it's going to stop here. 21.4 still. Still at 21.4.
I think it's 21.4.
I think we're going to call that 21.4. So that's the final temperature of both the water and the metal. 21.4 degrees Celsius. 21.4 degrees Celsius. Now, one thing I'm still missing is the mass of the metal. Now, I should have measured that before I started, but I didn't, so I figured I'd wait till I cooled it off in the water before I ran in and touched it again. So I need to dry this off, so I don't weigh the water. I just want the mass of the metal. And then I can weigh it. Make sure we're at 0. And my mass of my metal is 28.89 grams. 28.89 grams. So let's take all this data back to the computer and plug it in and calculate the specific heat of our metal and see how that matches up with the actual specific heat of the metal, which we happen to have, which is aluminum.
Well, here's the data you collected, Mr. Sams, right on the screen.
Alrighty.
So what have we got? We got the metal and we got the water. So we can assume that the energy lost by the metal is equal to energy gained by the water.
Right.
So we're going to use our equation, MC delta T. Actually, Q equals MC delta T equals Q equals MC delta T. But the cool thing is what? Q equals,
Q is the same.
The Q's are the same. So this refers to the metal, and this is the water. So the mass of the metal will be, what was it? 28.89 degrees Celsius, no, grams, times the specific heat of the metal.
Which we're trying to find.
That's going to be just C, times the change in temperature of the metal. Now, it went from 92. Now, wait a second. How did you get 92 degrees Celsius on that, Mr. Sams?
It was in the boiling water.
But I didn't measure. You didn't stick your thermometer in the metal.
No, but the metal had been in there for a few minutes, so we're assuming that the temperature of the metal
so
is
we're making
the
an
same as the
assumption,
water.
folks. 7.7 degrees Celsius. And so that's going to be equal to the mass of the water, which is 250 grams, times the specific heat of the water. Now, we do know that number,
4.18, always and forever.
4.18 joules per gram degrees Celsius. And the change in temperature went from 21.4 to 19.6. I can't do that in my head.
1.6.
1.6, yeah, 1.6 degrees Celsius. Okay, so now what I'm going to do is I'm going to multiply these numbers on the left. 28.89 times 70.7. So this is going to be 2,000. I'm going to round that. 2,043 times C. And that's going to be equal to, now the other side, 250 times 4.18 times 1.6. There's no variables on that side, so that's equal to 1672. Now this C right here is not like Celsius.
No.
It's just the variable.
Right, it's like X.
It's like X. So I'm going to divide both sides by 2,043. That crosses the 2,043 out, so I'll take 1,672 divided by 2043 gives me
0.818.
0.8 joules per gram degree Celsius. Now I think we should check and see how that
let's
compares.
go look back on the table.
We had the table a couple of screens ago, and
there it is.
Hold on, we got a. Aluminum was 0.90.
0.9. We got 0.8, or actually it was closer to 0.82. 0.90. That's not too bad.
Pretty good for doing it in like 3 minute experiment.
Yeah, and I think I spilled some water somewhere in there.
Yeah. So it was actually 0.82. My mistake here. So the real answer was 0.90, and we had 0.80. That's or 82, right? Actually, if we were to actually calculate the percentage error, how would we do that, Mr.
Yeah,
Sams?
well, we take what we got
0.82
minus what we should have got.
Minus 0.90.
All that divided by what we should have got.
0.90. So 0.08, negative 0.08, divided by 0.9 times 100 gives what, Ms. Sams?
Times 100, it's roughly 9% error.
9% error.
And it'd be negative 9%, meaning we were lower than the accepted value.
That's correct.
Yeah.
So, folks, that's how you do. You're actually going to do this experiment with maybe even aluminum. I don't know.
Yeah.
You'll have a metal, and you're going to try and find a specific heat. And, yeah. Hey, one thing I do want to say about this that I just thought of just now is, guys, we don't have negative numbers in our temperatures. They're always going to be positive. They're absolute values for you math geeks. Is that it doesn't really matter. It's a change in temperature. It's not going to be a negative or a positive number. It's just, well, it'll be positive. It'll be absolute value. So it makes your math a lot easier. Don't try and put like negative, because this actually went down 70 degrees.
Yeah.
You wouldn't say that should be a negative number. So that ends our podcast, Mr. Sams. Okay, we'll see you guys in class or on the internet. Bye.